Hi, my name's Jessica. I got my Uno starter kit in the mail and I just wanted to do an unboxing video because I thought it would be fun. Okay, enjoy.
Super Starter Uno R3 Project Kit. Let's see what's inside here. And so the table of contents for your kit. Every single one of these items, if you Google it with the word Arduino, you will find many tutorials that show you step by step how to use this stuff. So let's see what we got in here. Well, for starters, we have an Arduino board, which is awesome. This is a little microprocessor based on the Arduino board. It's an off-brand, but it works just as great. Anything you Google that says Arduino Uno, you're gonna find that those tutorials are applicable to this off-brand board. The main difference that I know about is that the cheaper off-brand boards typically have a cheaper FTDI chip, so that handles communication between the board and the computer, and with the cheaper boards, you sometimes need an additional driver to get them to talk to your computer. Don't worry about it. You can cross that bridge when you come to it. This has got everything you need to build amazing embedded systems, interactive projects. It's got it all. It's awesome. Okay. Well, we can connect that board to all the components in our kit with these amazing jumper wires. Cool. So for example, here's my board. Here's a jumper wire. It jumps right in there, bing! And you can see a little close-up. Wow, 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 wow. Okay, I guess you can't because my camera won't focus it. So let's say we want to jump that to a component. Let me find a component and show you what I'm talking about. Here's something cool. Okay, what's in this packet? Oh gosh. Shoot, don't do this. Don't do this with your teeth. Get scissors. Don't try this at home. Okay. Oh, that's not a great example. Shoot. Now I'm kind of like, my video is already failing. It hasn't even started. Okay. Oh, here, this is what I want. The breadboard. Okay, where do I show you? All right, let's open this bad boy up. We've got our Arduino breadboard. Why is it called a breadboard? I looked it up one day, but I kind of forgot why. Oh my gosh, and I'm in focus again. Ugh. You know, people on the internet, they make this all look so easy. All right, so let's say I have, an ultrasonic sensor. That's very cool. This ultrasonic sensor can tell me if something is in front of it because it will shoot out an ultrasonic pulse. It will receive it as it bounces off whatever's in front of it, and we can write a little program that we upload to our Arduino that can tell how long it took for that ultrasonic sound to go out and come back, and the amount of time it takes can be calculated to determine the distance between an object in front of this sensor and the sensor. Amazing. Well, this sensor has 4 pins, one for ground, one for trigger, one for echo, and one for power. It can go right into the breadboard, boop. See how easy that was? And we can connect it. So for example, I want to connect the ground pin to the ground pin on the Arduino. Boom. That's what the jumper wires are for. Are they not the best invention ever? Okay, put that aside, put that aside, put that aside. Boom, boom. What else we got in here? Ooh, we got a mini breadboard. Love it. We have a big breadboard and a mini breadboard. Both breadboards have adhesive backing. So if for some reason you decide to hack something that has to do with your body, you might need to just like put this on your forehead. I don't know. What is this? What do you think this is? This is so cool. So this actually, if you can tell, it has looks like the same shape as my Arduino board. Oh, that's because it is. These pins fit perfectly on top of the Arduino. Boom. There we go. Look at that. So if you prototype something with the breadboard in the Arduino, but you want to make it a little more robust, you can use this super handy shield to solder your components to the top. So you have this kind of like self-contained package. Because what you're going to find is as you're hacking, you're going to be prototyping with jumper wires in the breadboard, and you're going to have all kinds of wires and things are going to be crazy. Well, once you figure out what you've got, and that might not happen in the course of a hackathon, but it might happen over the course of a few weeks of development, you decide, okay, you know what your circuit is, you know how it works, the software is working, you supplant the circuit you've prototyped on your breadboard with something that's a little more robust because now it's soldered to this shield. So that is so cool that this kit comes with that. What else do we got in here? Oh my gosh, this is awesome. This is an LCD screen, and I'm gonna do, I love peeling these things off. It's so satisfying. Yes, okay. You know what is so awesome about this kit is this came with the pins pre-soldered. Are you kidding me? That's awesome. So if you want to have an LCD, LCD stands for liquid crystal display. If you want to have an LCD display in your kit, in your project, you got it right here. All you got to do is stick it in your breadboard because all these pins are space. Oh my gosh, you got to be careful though, because I get a little impatient and like, you know, these components were made alongside like a trillion components just like them, and you know, come on, let's be real. You got to, they're fragile. See, I'm like struggling right now to get that in the breadboard, but it will go in. I just need to be patient and I need to be gentle, and ta-da. Okay, but you know what, I screwed up because how are you going to connect your pins to that? Oh boy. Gotta put it. Okay, you get the idea. What's next? There's so much fun stuff in here. Okay, obviously we've got to connect our Arduino to the computer. So very handy. I believe the company that makes this, yes. Do you see that? I don't know how to pronounce it. It's Elegoooooo, kind of. Elegoooooo.com. Thank you very much for including the USB cable, because that's how we're going to actually connect our Arduino to our computer to upload our sketches to it, which are our little programs that put our Arduino in action. What else we got in here? LEDs. What's an LED but a light emitting diode? Nice. What else we got? Ooh, we got a battery, but what good? Oh, actually, to be specific, a powerful cell, extra heavy battery. I'm hoping, yes. Oh my gosh, this is awesome. Okay, this kit is like got everything you could ever need to get started with this stuff. So I'm gonna try to use my nails to open up this battery and to expose the, I don't know what those are called, the metal parts that conduct. All right, see that? Watch this. OMG, come on. This is like, just go together. Okay. Wow, I did it. Yes. That was anticlimactic. Well, this is the climax. Your Arduino can be powered one of two ways. When you plug it into the computer, it can actually get power from the USB port. And that's usually enough power to do any project that involves the components in this kit. If you were getting crazy and adding other motors, big motors that were pulling a lot of current, or, you know, fancy LED strips, the current, the 5 volts that the Arduino will snag from your computer might not cut it. The voltage might be fine. It's the amperage that'll get you. Well, look at this thing. There's another way to power your Arduino. Pop this in. OMG, we got power. What you see right there is the onboard LED at pin 13 blinking on and off, because the default sketch at least I use the word sketch to describe the program that's running on the Arduino. The default program running on the Arduino is called Blink. It's the equivalent of a Hello World program. It blinks an LED on and off at pin 13. Well, just to prove my point, check this out. We've got pin 13, and right next to pin 13 we have, so convenient, a ground pin. I'm going to take a blue light emitting diode. The shorter leg goes to ground. I like to think that if you're shorter, you're closer to the ground. Well, I'm not even 5 foot, so I can say that without any hesitation because I am a shorty. Look at that. Our onboard LED is blinking on and off because it's connected to pin 13, and then anything that we stick inside of the digital pin in 13 is also going to receive a pulse, and you can see it's pulsing 1, 2, 3, 4. I don't know how many milliseconds that is, but wow, that is amazing if you really think about it. I don't want to think about it. I can't, because I can't explain it. If I could explain what was happening, basically we have electricity converting to light. What? How? Okay, moving right along. Oh, we got a motor. That's pretty cool. Ooh, we got another motor. Ooh, what else do we got? We got any more motors? No, okay. This kit comes with 2 motors. It comes with a DC motor. DC stands for direct current. And a stepper motor. All right. If you want to add actuation to your project, you're going to be able to use one of these 2 motors. The little DC motor has a tiny little shaft, and the kit actually comes with this funny little fan that fits right on top of it. So if we added some power to this, we could get this spinning. Actually, we could do a little experiment. We had the LED blinking. Can we get this DC motor going off? So if I'm honest, I accidentally ripped off one of the leads. See, I have a black lead soldered to the motor, but the red lead that came with it, I broke off in my haste. Okay, that was like that. My bad, I failed. Well, I think I can kind of hold it in place and show you something cool. So I'm looking for the ground pin, because black, when I have a polarized component, that is to say a component that one lead always has to go to ground and one lead always has to go to power the digital pin. Black's going to go to ground, and then I'm going to kind of finagle this little red lead. It's going to go into pin 13. I don't know if this is going to work. This is like so sketchy. Oh my gosh, it's working. Okay, so what you're going to see is, if I can get my hands out of the way. Okay, I got to move this camera a little bit. I'm holding the fan, and I'm trying to keep clear of the fan blades. When I attach this to the DC motor is getting power. It's getting power the same way the LED was getting power, through pin 13. So that pin 13 is pulsing with power every, half second or whatever. Well, a DC motor, direct current motor, just needs some power to go forward. Well, how do we get it to go the other direction? We actually reverse polarity. I'm not going to do that physically. Instead, I'm going to think about how I can do that electronically. You can do that with something called a motor driver. A motor driver will automatically isn't the right word, but it will reverse the polarity of your current so that you can turn your motor forward and back, forward and back. Well, it just so happens this kit comes with an integrated circuit, an IC chip. IC stands for integrated circuit. This one in particular Nope, not that one. That's a shift register. We'll talk about that in a minute. Ooh, L293D. Does that mean anything to you? Well, if you Google that, and you Google that term, L293D, or I should say identifier, with the word motor, you're going to find something called an H-bridge circuit. And it's something that you can build with the components in your kit that would allow you to control this motor's motion forward and backwards, forward and backwards. When we connect this motor directly to power, it spins in one direction, and as fast as it spins is determined by the amount of current running to it. An H-bridge circuit gives you more control. Pretty cool. In terms of actuation, we also have that stepper motor I was talking about. Boop. Now, this is quite different from the DC motor in that it actually rotates in steps. Boop, 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 boop. And you can't just connect this to power and it do anything. You have to pulse electricity to it in a very particular way. To set it up from scratch is kind of annoying. Thank goodness this kit comes with something called a stepper motor driver. Yeah, let me show you. This right here is a stepper motor driver module. Look at that. See that? Boom. Watch this. Got it in. Yes. Well, now what? Now I have to connect this driver to the Arduino. We've got some pins right here that if we actually Googled this driver, we could find the tutorial to learn how to connect it to the Arduino. But these jumper cables I have are male to male, which I'm sure we can come up with some better terminology for that. But for now, I'm going to stick with it. We've got, oh gosh, I'm breaking these when I pull them out, so this isn't super. We got on one end a male end, and on the other end a male end. But what I really need is a female end here. Well, lo and behold, we got those in our kit. Yes. Okay. On one end, I have a female end, which will go boop. Okay, thank you very much. See that? And then the other end, the male end, fits perfectly into the Arduino. Where you put it on the Arduino, I'm just going to put it somewhere randomly. Don't take that too seriously because you need to look up a tutorial for the motor driver to learn where each of these cables plug into. Pretty cool, huh? Okay, moving right along. What else we got? Ooh, we've got a bunch of resistors. Okay, what do resistors do? Well, they do just that. They resist the flow of current through your circuit, blah, blah, blah. Okay, what else do we have? Oh my gosh, look. We have a joystick. It's so cute. It's like the world's cutest joystick. It smells like something's burning. That often happens when I work with electronics. This is so cool. You can add joystick control to your project. And you're gonna need those female to male pins to do it. We've got the female that plugs right into the driver, or the shield, I should say. And then the other male end, where was that in the view? Boop. That's gonna go right into the Arduino. So like, this shield actually tells you, okay, we have a pin for ground, a pin for 5 volts, a pin for our x-axis and our y-axis, and MS, something that probably stands for milliseconds, but I honestly don't know enough about joysticks to know what's really going on there. You'll obviously look this up in a tutorial, but I can tell you that ground is going to go to ground. Duh. Let's find ground. There it is. Oh my gosh. I'm already a fifth of the way there to having joystick control in my project. This kit is so cool. Oh my gosh, look. There's another motor. There's 3 motors in this kit. This motor is not like the others. No, no, no. This is a servo motor. And this is such a special motor in that we don't need it to, like the other motors, the DC motor, remember that one with the fan? and the stepper motor, both of those motors, you can't just plug them into the Arduino and then load a program to the Arduino and they work. You have to have this intermediary part. With the stepper motor, it's the shield, okay? It's an integrated circuit and some components. With your driver, it's the same thing, except you have to build that circuit yourself. Ugh. Okay, you might want to do that. It can be really fun. That's actually one of the first circuits I ever built was an H-bridge circuit. The servo motor is such a magical little machine. You can connect it directly to the Arduino. It doesn't have to have any intermediary circuitry. You can plug it directly into your Arduino and program it. So servo is usually my go-to because it's so quick for prototyping. We have in this little package some fun stuff. Let's see if I can open this up. We have some light sensitive resistors, just like the other resistors I showed you. This is a resistor. These resistors, there's so many because each set resists a very specific amount. So for example, I'm not going to get into it, but because I'm not very good at explaining it off the cuff, but we have some 1K resistors. Okay, if you put those in your circuit, the flow of current from an ohms perspective is reduced to 1K. You might not know what that means. We'll learn, okay? This, however, is a variable resistor. The amount of current that is resisted is determined by how much light this light-sensitive resistor sees. So this is so cool, especially if you want to build something like an electronic theremin. That's all I can think of. Excuse me. I'm making myself laugh. Okay. We have some diodes. These are very important. Some circuits require them. They have polarity. See that little silver strip? Electricity can only flow one direction through diodes, so they can protect a part of your circuit that might be fragile from electricity coming back and biting it in the butt. This, honestly, I don't know. Let's look. Let's look at our cheat sheet. A thermistor. Okay, I'm 99% sure this can tell you what the temperature is. Somebody tell me the truth. I might be wrong. These are little buttons. You might be like, those look like little weird insects. Well, they look that way because they have those little legs and they can go boop right into your breadboard. See what I'm doing there? Just like put them right in. Okay, you have to like really finagle them. You have to really work at it. You guys, this isn't going to be easy, but it's not going to be hard either. It's just that you've never done it before. So whenever you do something new, you just got to figure it out. And then you'll be like, oh my gosh, it's really not like anything crazy. I just need to keep trying. What else do we have in this kit? We're almost to the end. We have another display. This is a 7-segment display. Each segment of the number is an LED. All right, so if you want to learn how to add this to your project, the best advice I can give you, Google 7-segment display in Arduino and you'll find a tutorial. This is a relay. What if you want to turn the light in your room on and off? Your Arduino is kind of like a wimp in that. It can really only control components that are dealing with currents up to 5 volts. The relay is this powerful handshake component, which means that 5 volts, a current with 5 volts can control components that are connected to your AC grid in your house. Okay. We have a little mini 7-segment display. We had a 4 7-segment display. We have a mini one. Cool. Okay. We have a buzzer, a little piezo buzzer. What can you do with this? You can make really annoying sounds. I don't know what else you do with it, to be honest. This is a potentiometer. So we talked about resistors, and that resistors literally resist the flow of current through your circuit, and that they're a fixed value. Well, you can use something like a variable resistor, which is what this is, a potentiometer. It's a knob. If you've ever been in a car and you've turned the volume up and down, you've been turning a potentiometer, you've been turning a variable resistor, and it's this change in resistance that determines the volume produced. Pretty cool, huh? This right here, what is this? An IR receiver module. Oh, that's what we need to make this work. This kit comes with a, what is this called? A remote control or a clicker. I grew up in Oklahoma. We call these clickers. Well, this clicker works because when you press buttons, little IR beams shoot out of the top. Let me see if I can show you that. Well, how do you know if you've got your clicker pointing at your project? You've got to have an IR receiver. That's what that is. My camera won't focus because it's getting tired. And finally, this is the last thing, I think, yeah. This is a temperature and humidity module. So I told you there was a thermistor, and I thought the thermistor was, I lost it already, whoops. Oh, here it is. I don't know, I might be wrong about what the thermistor is. Somebody tell me. But this is both a temperature and a humidity module. So if you're growing plants, this could be very handy to have in your system. So I've made a mess, which is easy to do. But we can put it all back together into this super handy container that holds our super starter kit. Like I said, every single component in this kit, you can Google it in the word Arduino and you will find a plethora of tutorials that show you step by step how to put these components to work in your own projects. Cool.